all you. Good morning, whoever day. Me know who day, me know who head day. We see how all the pulling in. Pulling in fresh on the scene. After 11. Making sure all the audio coming through. Oh, Omar. Good morning, Healy. Where's the scene out there? Morning, Kaylee. Morning, Healy. Morning, Omar. Morning, Shalana. Come on in, come on in. Send out all the messages. Let everybody know we're here. Let everybody know we're here. Try a little soft music in the meantime. Waiting for everybody else to come in for a while. Morning, Gabe. Just check something here, see the audio coming through on the stream. Alright, leave that muted. Leave this muted. So although we are no echo, all I hear am good, right? Everybody could hear me good. I'll make sure everybody can hear me properly. Nice. Alright, so we are go wait. Alright. Are you hear me now? Testing. Tell me. I should be hearing me. Alright, cool. So, alright, so what I was saying is, right, this whole principle about LCM, we can use the LCM to express a sum of any number of fractions as one fraction. So, for example, in this one here, I had the sum and the difference of 4 fractions. And I use my whole LCM concept to bring all these fractions and express it as a single fraction. So just keep that in the back of your mind. When we solve the equations, we follow the steps. Rearrange, simplify, and divide by the coefficient on both sides. And we did one simple example, one very simple example. And then we went into the whole directed numbers and stuff. And we do a couple examples for that. And we finished off with an example where we solved for a variable. So today we continue in solving equations. But we're doing it catering for a different kind of situation that might arise. So just to do a little recap. If I recap, if I want to solve for x, and I have an equation that states 4x plus 3 is equal to 16 take away 7x. Well, the rules state that my x's must go on one side and everything else must go on the next side. So my 4x, he remains there. My minus 7 must jump the equal sign. So this here must jump the equal sign to come here. And this fella must also jump the equal sign to come here. So I will have 4x plus 7x is 16 take away 3. 7 and 4 is 11x is equal to 16 minus 3 is 13. I divide by 11 on both sides. And I get 11x over 11 is 13 over 11. This happens all the time. X is equal to 13 over 11. Now, I want you all to notice something here. In this question, all of my variables, all of them, are on the numerator. All of the variables are on the numerator. And this made it easier for me to rearrange. Alright? When the variables on the numerator, it's really easy for me to, alright, I will send you on that side, I will send you on the next side. As soon as a variable exists on a denominator, I end up in problems. So let me write that down. So far, all the numerators were on the, all the variables were on the numerator. If a variable, and remember a variable is things like x and y. If a variable is on the denominator, problems. Right? Problems. So what do we do? I mean, common sense could dictate. If it ain't broken, do fix it. So if I can work out, solve equations when I have my variables on a numerator and I have a method for it, well, I want to figure out if there's a way where I can bring all variables to the numerator in any question. So let me see what we can do. Put a little note here, right? Very, very important note I put in here. LCM can be used to express the sum or difference of fractions, of a number of fractions, as one fraction. Now this is an important skill, right? It's a very important skill. If I can express the sum or difference of a number of fractions as one fraction, then I'm making life a little easy for me to perform another operation. The next operation is cross multiplication. So to cross multiply, we must have one fraction on each side of the equal sign. Extremely important. We must have one fraction on each side of the equal sign. Now, what we could do for this? How we going to use this in solving equations where the variables are not on the numerator? These two things here we are going to combine them, right? So let me have an example here. If I want to solve for x, now there's another use for LCM which we will touch on after this first example. And I have 2 over x plus 1 over 3 is equal to 4. I want to know what x is, but x is on the denominator. I want to figure out a way in which I can bring x to the numerator. When I cross multiply, and let me give you an example for cross multiplication, right? How do we cross multiply? If I have a fraction on one side and the fraction is 2 over 7 is equal to a fraction on the next side, let me say is a over b. To cross multiply, I had to multiply denominator by the opposite numerator. This is 2b is equal to 7a. And this can only happen, I can only cross multiply if I have a fraction on each side of the equal sign. Now I want you to notice something with this cross multiplication process. Answer yourself, alright? When I cross multiply in this example I showed here, right? Which part of the somewhere down here. So when I cross multiply down there, I get rid of all denominators. Making things a little interesting now. I can use cross multiplication to bring all denominators up on the numerator. Yeah? Tell me if you've seen that. Make this a little bigger here. I can use cross multiplication to here. I can use cross multiplication to eliminate denominators in an equation. Tell me if you've seen that. Wait, I just trying out some stuff here. I just wanna. Oh, good lord. Yeah, I like this filter. Tell me if you've seen that while we play up with this here. This one nice and neutral. I will use this one. Tell me, do you all see that by cross multiplying, I am able to eliminate denominators? Look at this example here. I had denominators, I cross multiply, and I end up with no denominators. Well, to be fair, the denominator is 1. Right? It is 1, but it's understood. So I don't have something over something. I don't know how to put that. But in order to cross multiply, I must first have one fraction on each side. If by some chance I have more than one fraction on a side, I can either use LCM or I can multiply depending on the operation and make that fraction one fraction. So let's look at this example here. First thing that I notice, I have problems. My problem is my variable is on the denominator. Well, if my variable on the denominator, I want to bring him on the numerator. How do I bring him on the numerator? By cross multiplying. What is the condition to cross multiply? I must have a fraction on each side. Do I have a fraction on each side? I don't. How do I get a fraction on each side? LCM. Alright? It might just sound long and tedious, but it's very, very simple. LCM cross multiply. LCM cross multiply. Over and over and over again. So let's calculate the LCM. Now, if memory serves me correctly, I think I showed you all a shortcut in calculating the LCM of a fraction. I did not show you all the shortcut. Oh yes, I did, man. The trick. Adding or subtracting any two fractions. I did. Alright? So remember, it's this way first, that will be AY, then this way second, plus BX. Finally, this way third, over BY. So for this example, this way first, 14, this way first, 15, this way last, 21, 29 over 20. Again, this way first, 1 by 3 is 3, this way plus 2 over this way, we get 6. So I'm going to translate that information into the algebraic fraction. I'm going to express my two fractions as one fraction. So this goes first, 2 by 3 is 6. Then here, 1 by x is x, over. Then here, 3 by x is 3x, is equal to 4, and I'm writing it as a fraction, 4 over 1, just to visualize it. I have one fraction here. Just because I have more than one term on my numerator, that doesn't mean it's two fractions. It's one fraction. I can cross multiply. Remember, when I cross multiplying, the denominators multiply by the opposite numerators. So I will have 1 multiplied by 6 plus x is 4 multiplied by 3x. And I no longer have a denominator to work with. 1 by 6 plus x is 6 plus x. 4 3s are 12x. I rearrange, send the 12, send the 6. The x remains there. The 12 goes across, becomes minus 12x. 6 goes across, becomes minus 6. This is 1x, take away 12x, which is minus 11x, is equal to minus 6. I divide by minus 11 on both sides. And I get minus 11x over minus 11 is minus 6 over minus 11. All the time this will happen, and I will get the variable alone. A minus and a minus is a plus, so x is 6 over 11. Let me do our next example. Right? Solve for x. Let me say we have 6 over x plus 7 over 3 is equal to 2 over 4, no, 2 over 5 minus a third. Again, variable on the denominator, first thing I gravitate into is cross multiplying. I need to have one fraction on each side. I'll go and find my LCM on each side using my shortcut. So this on the left hand side here, I will have 6 3s are 18 plus 7x over 3x is equal to 6 take away 5 over 15. I can cross multiply. The 15 will multiply up here, and the 3x will multiply up here. So I will end up with 15 into 18 plus 7x is 3x into 6 take away 5 is 1. Let me get my calculator. Work out what 15 by 18 is on the calculator. 15 by 18 is 270 plus 15 by 7, 105x is equal to 3x. Rearrange, I'm moving the 3x across, I'm moving the 270 across. 150x take away 3x is 207, negative 270. 150 take away 3 is 147x is negative 270. I will divide by 147 on both sides. And I want to tell me, are you all getting the gist of this? Give me some answers in the chat. Over 147 is minus 270 over 147. You go cancel with you all the time. X is minus 270 over 147. No need to simplify it if you can't, right? When we reach that stage, we will learn how to simplify things easy. So I want to tell my fellow again the gist of this. So far, I'm still waiting for it in the chat, right? I know all I know it take a while for me to reach all you and all to reach back to me. So I'll continue with our next example here. Let me say, again, I'm solving for x, and I have 2 over 7 minus a quarter plus 3 over x is equal to 11 over 2. Now, first thing I notice again, x on the denominator. No problem. I want x on the numerator. I had to cross multiply. Before I cross multiply, I had to find the LCM. But on my left hand side, I have 3 fractions. On the right hand side, I have 1 fraction. I can't use the shortcut no more. But I can be smart about it. There are more than one way we can do questions like this. Right? This is just one of the various ways in which we can solve an equation. And there are different types of equations. If I decide, here was the scene. I'm going to find the LCM on the left and express those 3 fractions as 1 fraction. Ain't no problem with that. Let's go ahead and do that. Right, so I'm going to do this question one of two ways. I'm going to find my LCM on the left is equal to 11 over 2. My LCM is 7 into 4 into x. Big denominator over small denominator multiplied by the numerator. I will get my big denominator, which is this fella here, divided by 7. So the 7's cancel out. So I'll have 4 by x by 2. So 2 into 4x. Take away. For my second fraction, the 4's will cancel out. So I will have 1 into 7x. And for the third fraction, my x's will cancel out. I'll have plus 3 into 7 by 4 is equal to 11 over 2. No problem. 8x minus 7x plus 7 by 3 by 4. Again, I jump in on my calculator. 7 by 3 by 4, 84. All over 28x is equal to 11 over 2. I have one fraction here, but man, here's one fraction. I could cross multiply. U multiplying by u and u multiplying by u. Well, I will have 2 into 8x minus 7x is 1x. 8 minus 7 is 1. So I got x plus 84 is 11 into 28x. 2x plus 168 is 11 by 28, 308. Move the 308, move the 168. 2x take away 308x is minus 168 is minus 306x, sorry, is minus 168 is minus 168. I must divide by negative 306 on both sides. When I do that, I get minus 306x over minus 306 is minus 168 over minus 306. You go cancel with you all the time. A minus and a minus is a plus. 168 over 306. I'm looking out for questions, right? While I do the second method, I'm looking out for questions. Or I'm looking at my equation. 2 over 7 take away 1 over 4 plus 3 over x is equal to 11 over 2. This is a regular equation. I can rearrange the equation as long as I change my signs if it jumps the equal sign. So what I'm going to do, I'm going to just send one of the terms across on the next side. It doesn't matter which term you send, as long as you send one term on the next side, it will make life a little bit easier. I'm sending the negative a quarter across. So I will get 2 over 7 plus 3 over x is 11 over 2 plus a quarter. I can use my shortcut to LCM now. My first two fractions, 8 2s are 16 plus 7 3s are 21 over 56 is equal to, where's my x? Over 3 over x, sorry, why put 3 over 8? My bad. 3 over x. I get 2x plus 21 over 7x is 44 plus 2 over 8. I could cross multiply here. 8 into 2x plus 21 is 7x into 44 plus 2 is 46. I get 16x plus 21 by 8, 168, is equal to 7 by 46, 322. rearrange. 16x take away 322x is minus 168. 16 take away 322 minus 306x is minus 168. Divide by, shucks, don't have to write it in words, put it in symbols. Divide by minus 306 on both sides, and I get minus 306 over x over minus 306 is minus 168 over minus 306. You go cancel with you. X is minus and a minus is a plus. 168 over 306. So I get the same answer. So you see, sometimes it make a little sense to just send a fraction on the next side, so I could make life easier for me in terms of this shortcut to my multiplication process. The only reason we're going through this here, you realize everything is repeat. LCM cross multiply, rearrange and solve. LCM cross multiply, rearrange and solve over and over again. And this happens if the variable is on the denominator. So what I'm going to do, like I said in the last class, I think half an hour is more than enough for you all to watch a video and take down the notes and try examples. So what I will do, I will just put a couple questions here, and I want you all to do them for me. When you do the questions, upload your solutions on the classroom. So the questions are: solve for x. Right? You will have the notes from Remedial Classes 2 and 3 to help you with this. Solve for x. 2 into x plus 4 minus 3 into 2x minus 1 is equal to 16. Number 2, 4 over 2x minus 3 over 7 is 11 over 4 minus 1 over 5. And 3, ask questions now as I'm writing this down. And number 3, 4 over 7x plus 3 over 7 minus 1 over 6 is equal to 2/3 plus 1 over 2. All right, so give this one a try. Yeah, give this a try. All right, so again, I'm looking out for questions. If you all have no questions, say, sir, I have no questions. All right. The easiest way to communicate with me is just post something on the Google Classroom. I usually check it a couple times for the week. I don't get notifications from that because I have so much on my school classroom already. So I don't want the notifications get mixed up. So I'm looking out for any questions. Talk to me. I'm listening. Now, once you take down the notes, it gets easier. Right? It does get easier as you take down the notes. So don't be afraid to just take it down, try it first, and see where is the scene. How many solutions do they have to find the answers for these questions? Well, Alright, so let me gravitate this here. Omar, what I will suggest you do, watch back the video and take down your notes. Alright, this video will go public after. Alright, as soon as this is finished, this video will go public. So watch back the video and take down your notes as the video goes on, right? So to answer Kaylee's question, Kaylee asked, how many solutions do they have to find the answers for these questions? A solution to a question is the answer to the question. So for example, in example 1, x is equal to 6 over 11. That is called the solution to the question. X is minus 270 over 144 is the solution to the question. X is 168 over 306. That is the solution to the question. So I think you're asking how many methods do they have to find the answers for these questions? It have plenty, right? It does have more than one. It have more than two. As we get better with algebra, you all will realize, well, you know what? This question here, I can do it like this, or I can do it like that. And as we go along and you get better in algebra and you realize, well, you know, this equation, it looks in a certain way. I must use a certain method to solve this equation. Just like how you will watch a square and say, that is a square. You see the square by recognizing it's a square from learning ever since. That is the shape of a square. So when you see certain equations, you'll be like, aha, that is a linear equation. I have to go through this method to solve this equation. When you see a next equation, aha, that is a quadratic equation. I have to go through a different method to solve the quadratic equation. So practice, understanding how equations look and what they are called. Like all of these equations here are called linear equations. So if I were to draw all of this on a graph, I'll get a line. All right, I will get a line, some form of a line. So yeah, I think that was your question, Kaylee. How many methods are there to solve the questions? All right, guys. So if anybody have any questions, you can do one of two things. Either comment under the video asking a question pertaining to the video. I think that will be a little easier because I know which video are they referring to. And you can always communicate with me on the Google Classroom. So with that being said, I will see everybody next week. Next week, I am anticipating we have another synchronous class. So I'll be here, you'll be there, and we will move forward in continuing this, noticing different types of equations and how they actually look on a graph. So next week, we are actually seeing mathematics be applied, and we're seeing what happens to the equations and what they do. All right, so I'll see everybody next week. All right, have a safe week, guys. Enjoy school, study your work, take down your notes. To get good at maths, you have to do it. You can't just read it and expect to get good at it. You have to practice. Okay? So please practice your work for all subject areas, and I'll see everybody next week.